Okay, today we are learning how to solve a parallel.
It's a hard one.
circuit. And the parallel circuit is quite easy to solve, just like the series was. There are some steps that we follow, and if we follow the steps, we gotta make. We can also find the effective resistance of a parallel circuit. But to find the effective resistance of a parallel circuit, if you remember, every time we added a resistor, the overall resistance got smaller. So there was an inverse relationship there. So what happens is, to find the effective resistance, we say 1 over the effective resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc., etc. So we add them up that way. Weird, right? Yes. Then we said what was the same in a parallel circuit is the voltage drop. So in 2, we can figure out the V drop right off the bat. The V drop for each section is equal to the, because each one is connected separately to the battery, and so it has the total voltage is going to be lost in each section. So it's super duper simple. In section 3, we find the current, and again, current is equal to voltage over resistance, same as we had before. And so here we do this for each branch. We find the voltage drop in a series circuit for each individual resistor, and the current was the same. Here the voltage is going to be the same, but the current we have to calculate for each one. So we do this for each resistor. And then for find I. Lastly, we will find I in different spots and do a little mental check like we did with the series. So, yesterday we had three resistors hooked up to a battery, right?
Yes.
So we're going to do that exact same equipment
Today.
except we are going to hook them in parallel. So we again are going to have the exact same 3 resistors. We had a 10 ohm resistor, we had a 20 ohm resistor, we had a 30 ohm resistor, and we had a battery that was 12 volts. Right? So if we do this, we can do the same thing here. So how do we find the effective resistance? We have to do 1 over it. The shortcut way of typing in 1 over the whatever is you look for a button on your calculator that says x to the minus 1. What that does is it takes whatever number and flips it over to be 1 over that number. So you're just going to hit 10 to the minus 1 plus 20 to the minus 1 plus 30 to the minus 1 equals, and then you're going to hit x to the minus 1 at the end, because you need to invert your answer also, because that'll give you 1 over RE, and we want RE, not 1 over RE. So try that.
When we do it, we click that again.
Yeah, after you hit equals, you do it one more time. And ideally you should have found that that is.
So we know, right?
5.45.
5.45454545454545 on nauseam on 9. Well, your calculator eventually just rounds where it wants to round, but it actually goes on. Okay, so that's our effective resistance.
So we don't want for effect comes out.
What?
Do it again.
Again, technically, electricity doesn't like to round at all, but obviously you have to round at some point.
True.
But, yeah. Okay, now, the voltage drop. How much voltage am I going to lose when I go across the 10 ohm resistor? All of it. Every time I complete the circuit and come back to the battery, I have lost all the voltage. So going across 10, I lost 12. Going across 20, I lost 12. Going across 30, I lost 12. So for all three of them, the voltage drop was 12 volts. Tough stuff, right?
Yes, sir.
Okay, so then we get to part 3. How much current is going through each one? Well, since they are essentially each hooked up separately, we figure that out. I is just V over R. So I have 12 over 10, and I have 12 over 20, and I have 12 over 30. 12 over 10, of course, is 1.2 amps. 12 over 20 is going to be 0.6 amps. 12 over 30 is going to be 0.4 amps. So we say how much current is going through this wire right here? 1.2. How much is going through this wire right here? 0.6. And how much is going through this wire right here? 0.4. So how much current is going through this wire or that wire?
12.
10.
1.
Oh, yeah, 1. My bad.
Yeah. Just leave off the decimals, it looks like a 10. Anyway, 0.6 and 0.4 both had to go through this wire, right? So coming out of the battery, I had to go through this wire to get to the 0.6, and I had to go through this to go to the 0.4. So both of these currents had to flow through this wire. So how much had to flow through this wire or this wire? That had to be 2.2 amps, right? So the total current must have been 2.2 amps. Now, if V equals IR, if I take the total current times the effective resistance,
It should equal
that should equal what voltage?
to 12. But
See if it works.
Approximately.
2.2.
11.9999999.
it equals to 12.
Hey, I got 11.9999999. Is that close enough to 12? Yes, because again, electricity doesn't round even though you do. So that's going to work like that. How many people thought that was really, really cake? Cake? Yeah.
So we're hanging.
So now,
There goes the recording.
if we look at how much power we used last time, we said that if we're in parallel versus if we're in series, which one uses more power?
Parallel.
Parallel, we said use more power. So again, power is IV. So the total current we had here was 2.2, and the total voltage we had here was 12. So the total power we use this way is 26.4. So we're using 26.4 watts of power. Now, if you looked at yesterday's notes, when we were talking about series, and we had the exact same setup, does anybody remember what the current was there? We still had 12 volts. But when we hooked up the current last time, okay, and we had to add up the resistors, just straight add, so 10 plus 20 plus 30 was 60, right? So 12 divided by 60 gave us 0.2 amps last time. So we only had 0.2 amps last time, so that's going to give me 2.4 watts. You see how when we hook up the exact same components in parallel, we have this power. In series, we only have that power. Power usage is always much, much smaller in series than it is in parallel. Any questions there? super duper simple, right? Okay, so this is how you do parallel. Again, if you understand series by itself and parallel by itself, once we throw them together into complicated circuits, then you're gonna be in great shape. Now, as far as the AP test is concerned, this is all they care about, is series and parallel. It's in the AP Physics 2 test if you want to know more complicated stuff, but really all you need to know are the basics of what we've taught you the last couple of days as far as the test goes. Of course, my test is a little bit different, but
You're actually gonna give us like parallel